Hello and welcome to the first video in our series for Math 1720. Our first unit is on the unit circle. Now that might be a little surprising to many people because when you hear the word trigonometry, many people think triangles, specifically right triangles, which is a triangle where one of the interior angles is exactly 90 degrees, or right angle. That's what a lot of people think of when they are talking about trigonometry. Because then the Pythagorean theorem comes into play, SOHCAHTOA, whatever that means comes into play, right? Opposite over hypotenuse, ratios of sides, all that comes into play with right triangles. And that was what a lot of you probably did, maybe all that a lot of you did, when you were first exposed to trigonometry. And so because of that, we are not going to start with triangles. In this class, we are going to start with the unit circle. We're going to start with something not a triangle, and then build towards something that is a triangle. So that will be our main effort for the first several weeks of this course. So the unit circle is where we'll start. We're going to end with angle measure, which is going to be our transition, our bridge into right triangles and general triangles. But first of all, a little bit of a maybe more in-depth look of what happens these first few weeks. First, we make the unit circle, and then we start moving on the unit circle, which is maybe a foreign concept to a lot of you, moving along the unit circle. So instead of moving back and forth on a line, we're going to move around a circle. And then we're going to use that motion to define all of the major trigonometric functions. Things like sine, cosine, tangent, all of those can be defined as motion on the unit circle. And that's what we'll be doing. Following that, we're going to graph some functions, graph sines and cosines, graph tangent, graph all those things, do transformations on them. And then we're going to invert them. We're going to find the inverse trigonometric functions like arcsine and arccosine. And then finally, as I had said, we're going to move away from the unit circle towards more general rotation, general angle measure, and that will be our bridge, our connecting point into triangle stuff. So that's going to be our first few weeks. I'm pretty excited about this. I rather like the way this is structured, not just with how we're doing the unit circle first, kind of a more foreign concept, to have you marry that in with triangles as we go. I do like that, but I also like the approach of having me, instead of lecturing this to you for hours on end every week, I lecture to you for minutes on end, and then all that remaining time will just be spent with you putting the pieces together in class with me, or out of class as you prepare for the next class or following class. It's going to be a good structure. I'm very excited for what we're doing here. Alright, well, enough preamble, enough setting up for what's going to happen. Let's actually get into it. I want us to talk about moving away from functions ever so briefly. I want us to go way back to the good old days, the halcyon days of our youth, when mathematics was nothing more than solve for x. That was probably all you did for most of your algebra courses. If you took college algebra or transitional algebra, you probably just did nothing but solving for x for weeks. You would do the quadratic formula, then you do factoring, then you do synthetic division, you do all these methods for solving equations. So let's pick up from there. You know, when I ask you to solve an equation, that means something very specific. And it's not just get the equation manipulated down to x equals number, although a lot of people tend to think of it as that. Procedurally, that is definitely part of it, but when I ask you to solve an equation, what I'm really asking for is for this equation, say this one right here, I want you to tell me all the numbers, all the values I can put in for x that make it be true. Not to say that x can't be anything else, right? I could put negative 17 billion into this equation for x if I wanted. I could substitute that value. All I would have at the end of the day, though, is an equation that is false. And so, practically speaking, that's not really useful. It's achievable, right? In mathematics, we can work with case false, but really, what's more important, what's harder to get to, what's more useful is when it's true. And so a lot of what you've done up till now has been finding solution sets, finding values that make equations true. And yes, this is true when x is 2 or x is 3. You could have evaluated that by quadratic formula or factoring, or if you really felt crazy, you could have done synthetic division, right, using rational root theorem. You could have done whatever. But that's not really the focus of this class. We're not going to solve a lot of equations. We're going to solve some, but we're not going to solve a lot. What I want to say though right now is this is an equation in one single variable, specifically x. Right? I don't have to have that. I can have equations in x and y. I can have equations in x, y, and z. I can have equations in as many variables as I choose. Most of what you've had so far in your life has been in one variable. But now, let's look at the equation x squared plus y squared equals 1. That is an equation in two variables. And it's going to happen that all of our solutions aren't going to just be x equals number or y equals number. When we're finding solutions to this, we're finding ordered pairs, right? We're finding this equation is true when x is some number and y is also some number. Maybe the same number, maybe not, but that's how you would find solutions to an equation in two variables. Which brings me to a very simple observation. The solutions to any equation in two variables will be ordered pairs. So if you had an equation in three variables, say x, y, and z, then your solution set would have ordered triples, right? So x, comma, y, comma, z. But since it's in two variables, we're going to have x, comma, y as our solutions. And one way we could find solutions is to just take some number, substitute that in for x, and see what y would necessarily have to be for it to be true, right? Because if I put a number in for x, that makes this an equation in one variable. And suddenly all of our techniques and tools that we've had exposed to us before, we can use now, right? I can take the square root of both sides, and I get y is equal to plus or minus 1. So when x is 0, y can either be 1 or negative 1, which gives me these two ordered pairs as solutions to my equation. So we have now two solutions, and you probably see that we can get two more just by taking 0 and substituting that in for the y value, and resolving for x equal plus or minus 1. So we actually have 4, but that's a good start. Let's get a few more. Specifically taking x equal to a half, that squares out to be a fourth, so I've got a fourth plus y squared equals 1. Move the fourth over, take the square root of both sides. Y is equal to plus or minus the square root of 3 over the square root of 4. Y is equal to plus or minus root 3 over 2. That's usually how we say that. Now, not just any value we want, we can stick in and get a solution out. For instance, if I take x equal 2, that would mean that y squared is negative 3. Y has to be plus or minus root 3i, which is not a real number, which is fine in and of itself, but for this class, we want real solutions, we want real valued functions, so there is no real solution when x equals 2. That would not be part of our solution set. That's fine too. Right, so we have now quite a few points, right? We've got these four, 0, 1, 1, 0, etc., etc. And we've got now a half root 3 over 2, a half negative root 3 over 2. And actually, from there, we get quite a few more, right? If you have any one point on the unit circle, then you actually have as many as 7 others. And that's because, well, if you square an x-coordinate, that's always positive. So plus or minus a half, that's going to work. If you square a negative, you still get a positive. So plus or minus root 3 over 2, that works. And also, because it's x squared plus y squared, you can swap the x and the y for the x, and you'd still have a solution, assuming what you started with is a solution. So actually you have plus or minus a half, plus or minus root 3 over 2, plus or minus root 3 over 2, comma, plus or minus a half. We have actually now 12 points that are on our circle. Spoilers, it is a circle. So that's one way to get points on our unit circle. Just plug in a value for x or plug in a value for y and see what the companion variable would have to be. That's one way to do things. Now we're going to look in the next video different ways, maybe more efficient ways to get more points, but that is one way of doing it. So I want to end with this question, and then we'll see you in the next video. Is the ordered pair 0.8, 0.6, which is 4/5, 3/5, is that a solution? Is that a point on our unit circle? Is that a solution to x squared plus y squared equals 1? So you go ahead and answer that, and I'll see you in the next video.